Hey folks, good day, and I'm here to help you out with a couple of very, very common mistakes that occur in algebra. And one of them is called the freshman's mistake. Now, it's very common right here to believe that this statement is true, but it's actually false for most cases. Just if you choose x equals 0 and y equals 1, this would actually be true because you would get 1 squared is equal to 1 squared is equal to 1. But in general, it's false. As tempting as it is, it looks like this would be true, but it's not now. What I did here is just arbitrarily pick two choices for x and y. I just picked 3 and 2 to keep the calculation simple. Now, if you thought this so-called freshman's mistake was true, you would square the 3, you would square the 2, and you get 9 plus 4 is equal to 13. However, watch what happens if you just add up 3 plus 2. Well, you get 5. 5 squared is 25. So we can see these two numbers aren't equal to each other. 25 does not equal to 13. But this is what you would get if you committed the so-called freshman's mistake. All right. Now they called it that back long, long ago when people actually took it humorously. Today, people are a little more offended by things like that, so you don't quite see it called that this frequently. But it happens to us all. It happens to people in advanced calculus, people taking differential equations. It's because it's just tempting to think you can get away with that. Now let's take a look at this next example. This is also a super common mistake. You've learned all the way back middle school that square rooting and squaring are what they call inverse functions. So what would be more tempting than just to remove the square and call it x plus y? All right. And again, it looks very natural. And it does happen if these happen to be a product. But here there are some. So if you take a look at this example, I've picked x equal to 4, y equal to 3. All right. And so what you get right here, if you commit this mistake, is 4 plus 3 is equal to 7, right? You just wipe out. Wouldn't it be nice if it was that easy? But really, if you perform the arithmetic within the radical symbol, you get 16 plus 9. 4 squared is 16, 3 squared is 9, right? 16 plus 9, 25 square root is 5. So again, you can see these are not equal to each other. So again, just watch these mistakes, folks. And I intentionally put does not equal to indicate they are false. Now they are true for what they call the trivial cases like x equals 0, y equals 1, or the other way around. And this kind of is illustrative of that right down here. X plus y squared algebraically means just to write x plus y times x plus y, and you can use what they call the distributive property. You just see all these little arcs where it's all happening, and that leads to the presence of all of these terms down here. And you can see you have this middle term, or this sometimes called cross terms, in the middle here. So that would totally, if you believe this, you know that there's no way this could be true unless x or y happen to be 0. And you see this proves it algebraically. If x or y was equal to 0, then this so-called freshman's mistake would be true. But those are just two very special cases. In general, it's not true. I hope this helps, folks, because it's a common mistake at all levels. Have a good day.